Now, two more terms, new terms related to this laboratory tests or diagnostic parameters. And for this, I have a question first. Why is ordering random blood glucose not suggested in family practice? First, you should know that this is not suggested. Yes, believe me, it is not suggested. In general practice, we don't, I am a GP, we don't administer so many tests in general. Blood glucose also, as for screening purposes, we don't do it. But if somebody has a symptom, of course, you may administer it. And why it is almost a routine in endocrinology outpatients or in a hospital setting? The answer will follow here. Here we have now two new terms, the diagnostic indices, namely the positive predictive value and the negative predictive value. So besides the sensitivity and specificity, which we just mentioned before, we have also some other indicators important for us to make decisions about the laboratory tests or diagnostic tests which we apply. In this case, you remember the sensitivity was about the truly diseased people, this column, and the specificity was about the healthy people, this column. Now, the positive predictive value is related with the test positive people. What proportion of the test positive people in my group are really test positive, have really the disease, So this one, true positives divided by true positives plus false positives. And negative predictive value, on the other hand, means it's about this one, the truly negatives. Among the test's negative people, what is the probability or proportion of those having really no disease, being really healthy? And the important point here I have to mention is that it is directly related, enormously related, these two indicators, positive predictive value and negative predictive value, with prevalence. If you have low prevalence, or you may have a very high sensitivity, specificity, but the test will have no value because the positive predictive value will be low. What means low prevalence? Prevalence is having the disease. Imagine this cell here has a very small number. If this number is very small, the positive predictive value, because this is the denominator, on the numerator, because therefore the positive predictive value will always be low. Also this negative predictive value. If you have small number of people, so the test may not apply. If the prevalence is low, the test may not apply in your context, although it is a very good test with a very high sensitivity and specificity. Okay. Here, a summary of all this. People with the disease, here, this time, not in the column, sorry, in the row, people with the disease and healthy people. You administer a test. You administer the test and you check the sensitivity, let's say. What was sensitivity? Among the diseased people in this red box, what is the probability of getting a positive test? 2 divided by 2, that is 1. Sensitivity in this case is 100% or 1. What is the specificity? Specificity is about the healthy people. Among the healthy people, what is the probability of returning a negative test? That is 9,996 divided by 9,998. So this is also almost 1. it is 0.98 or something, I believe. So this is our sensitivity and specificity. What about the positive predictive value? Positive predictive value was about the people with the positive test. And here I have 4 people with the positive test. Very low prevalence. And the prevalence is 4 out of how many? 10,000. 9,996 plus 4, 10,000. Out of these 10,000 people, I have only 4 with the disease, very low prevalence. Since the prevalence is very low, my positive predictive value, although I have a very good test with very high sensitivity, very high specificity, my positive predictive value will be 2 divided by 2 plus 2, 4. That means 0.45 or 50%. So very not so high. It's like tossing a coin. Positive predictive value. Okay, that was a summary of the positive predictive value, negative predictive value, and sensitivity and specificity. Let us stop recording